In our last video, we talked about how to find the total number of protons, neutrons, and electrons in an atom, given that atom's mass number, atomic number, and charge. In this video, we're going to go over how to figure out the average atomic mass of an element. You are going to need your notes, you're going to need something to write with, and for today, you are going to need a calculator because I am going to have you do an example. All right, so once you have everything you need there ready, let's go. So one of the things to keep in mind is that when we were working previously on our proton, neutron, electron counting, we were talking about one atom of an element, or what we call a nuclide, right? So a single atom, a single isotope, a single ion, just one particle. Average atomic mass deals with a large sample of that element, right? So the atomic mass is the weighted average of the masses of each isotope that we're working with. A weighted average works the same way it does in classes that use category weights, right? So for example, if something says like your tests are 40% of the grade, your quizzes are 30% of the grade, and your homework is 30% of the grade, then what you do is you take the average of each of those things, multiply by the percentage, and then add up. We're going to do the same thing here. What you do is you take the mass of the isotope that you're given and you multiply it by its abundance. Change the percentage into a decimal before you multiply so you get it correctly. And then simply add up the answers for each of those and you'll get your final average atomic mass. All right, so that's all you have to do to figure out average atomic mass. So here's the example we're going to work with. What I'd like you to do is I would like you to try to tell me the average atomic mass. This is actually not carbon. Sorry, I changed this slide a little bit. This is actually silicon. Right, so I want you to find the average atomic mass of silicon given the data below. I gave you the mass of each of the isotopes and I gave you their abundances. Try it for yourself, pause the video, and pick it back up when you believe you have an answer. Okay, so hopefully you have an answer for these. So first thing I want to do is I want to turn these percentages into decimals. To do that, I just move the decimal point to the left 2 places, right? So 0.9293. This I have to put a 0 in front, so I have 0.0468 and 0.0309, right? And then I'm going to multiply these across. When I multiply this top column across, that gives me 25.81. This second column gives me 1.35. And this last column gives me 0.93. Then to get the average atomic mass, I just add these up, right? So I add them up, I get 28.09, and my unit for this, because every numerical answer that you're giving me this year has to have a unit, is going to be an AMU. This is the average atomic mass of silicon, and this should match pretty closely what you get on the periodic table. And speaking of which, point of order. When I give you examples on a quiz or on a test, they may not match up to what you see on the periodic table, right? So if I gave you silicon on a quiz or a test, for example, it may give you an average mass of like 34. That's not an issue. That's not a bug. Again, the reason why I do that is to make sure you just can't take the average mass of the element from the table and plug that in as your answer and hope to get credit for it. What I also do a lot is I also give you fake elements. So for example, what is the average atomic mass of the element vegium, where I give you peas, carrots, and cucumbers as your different isotopes, and I give you masses to work with. right? So they may not work out that way on a test or a quiz. That is by design. All right, so that is average atomic mass. In our next video, which will be the last one for this chapter, we're going to be talking about the periodic table and properties of different types of elements.